Okay, problem 2. Now in this problem we've got 2 power cables, actually we've got 3 power cables. We've got a red one, a blue one and a green one. Now the red power cable and the blue power cable are carrying the same current, exactly the same current in this direction, indicated by this red and blue arrow. So this red cable here, this power cable here represents that red one there. The blue one here, of course, is this blue one here. And now this third power cable, that's the third one, and that's this one here. So this is like an orthogonal three-dimensional diagram, and this diagram over here is looking at them end on, as if we were looking at the arrangement from that direction. Now a couple of things to note, that the distance from the green cable to the red cable, this distance here, is the same as the distance from the green cable to the blue cable. The other thing to note is that it forms a right angle triangle. And finally, there is a current travelling through the green cable, but it's different to these currents. The current through the green cable is 5 amps, and it's travelling in this direction. So the problem is this. The question is, what is the direction and value of the net force acting on the green conductor? So we want the value and the direction of the net magnetic force actually, on the green conductor. Actually, I should tell you it's actually the net force. What's the net magnetic force per meter of wire? So that's per meter of cable. So because it's per meter, we actually don't need to know the length. We can just work it out for an imaginary 1 meter. So we're just working out per meter of cable length. So what I want you to do now is have a go and see if you can solve that problem. And then in a moment you can access the video to look at the solution. Thank you.